we have a value of a sample proportion, p hat, that provides an estimate for the population proportion. So let's say that this was the actual population proportion, and that this is our sample proportion. So the estimate is off by 0.058. If we added 0.058 to 0.426, we would get 0.484. So this difference represents the error in the estimate. But remember, you're taking a sample and you're getting that p hat. If we took a different sample, it's likely that we would get a different p hat, right? So maybe we got this p hat, 0.498. That results in an estimation error of 0.014, which would be kind of a little bit better, right? You're closer to the actual value. But when you take these samples, you don't know that you got the best sample that you could, or you got kind of a crappy sample, right? So just note that different samples will produce different estimates. And those estimates will have different estimation errors. Okay. So we have what we call the margin of error. The margin of error of a statistic is the maximum likely estimation error. It's the one we would get most often. And we say that it is unusual for an estimate to differ from the actual value of the population characteristic by more than that margin of error. Okay. So let's think about, get this into practice a little bit to kind of see what's going on visually. So remember that the sampling distribution had certain properties. The mean of the sampling distribution is the population proportion. The standard deviation of the sampling distribution is the standard deviation, the standard error, the square root of p times 1 minus p all over n. And if n is large enough, then p hat, the p hat sampling distribution is approximately normal. Remember, we needed to have n times p greater than or equal to 10, n times 1 minus p greater than or equal to 10. Or we needed to be able to say we should expect 10 successes and at least 10 failures. So when those properties hold, we can use what we know about normal distributions to tell us how p hat behaves as an estimator of p. Okay. So the thing that we have to remember about normal distributions is, in a standard normal distribution, our empirical rule says that we know about 95% of the time the value of the variable will be between negative 1.96 and a positive 9.16. Remember, we calculated that. We looked at, the standard deviations, negative 1, negative 2, 1, 2, and we looked up 95%. We wanted 95% in there. So we wanted the 0.025 and 0.025. We wanted the bottom here, and we could do 95 there. But we looked at this about a chapter or two ago. Okay, so maybe chapter 6. So in this tailed area, right, which is what we have here, we found these values. And in the central area, that's 95% of the area under that curve. And so 95% of the observed values will be within 1.96 standard deviations of the mean. So if n is large, the p-hat sampling distribution is approximately normal with mean of p and standard area error of this. We know that. So what that tells us is that about 9% of the possible, or I'm sorry, 95% of the possible values for p-hat fall within 1.96 standard deviations of the standard error, or of the standard deviation of that distribution, of that sampling distribution. So this is what we call the margin of error, right? 1.96 times the standard error of p-hat. Now the problem is that we don't ever really know what P is. In all of our examples so far, we've said P is this, right? Because we had to kind of understand what we were doing. But statisticians don't know what P is, otherwise there would be no need for statistics. If they had the actual population characteristic, they wouldn't need to take a sample and make decisions based on it. So, how do we find that margin of error if we really don't know what P is? Well, if we have certain conditions, if certain conditions are met, then we can replace P with p-hat. And we'll still call it the margin of error, but it really becomes an estimated margin of error. And the conditions that must be met in order to use p-hat instead of P are: first, we have to have a sample that is a random sample from the population of interest. If we don't know for sure that it is a random sample, we have to at least be able to say that it's reasonable to think that the sample is representative of the population. And then finally, the sample size has to be large enough. We have to be able to get at least 10 successes and 10 failures. If these conditions are not met, we cannot estimate the margin of error using p-hat instead of P. Okay. So how do we interpret the margin of error once we get it? Well, we say that it would be unusual for the sample proportion to differ from the actual value of the population proportion by more than the margin of error. So how we would say that, we would say for 95% of all random samples, the estimation error would be less than the margin of error. Okay. And remember that we used 1.96, which determined 95% of the error of the area under the curve. You could use a different z-score and it would give you a different percent. So if you used a different, something that corresponded to 90%, you would say for 90% of all random samples, the estimation error would be less than, but you'd use a different z-score up here when you calculated it. Okay. For the most part in here, we're going to stick with 1.96 and go for 95%. Okay, it is a very common thing in statistics. So let's take a look at an example and see how we go through trying to compute the margin of error. Okay. Based on a representative sample of 511 U.S. teenagers aged 12 to 17, International Communications Research estimated that the proportion of teens who support keeping the legal drinking age at 21 is 0.64. P hat is equal to 0.64 with a margin of error of 0.04. Okay, so let's see how they figured this out. First of all, you have to check your conditions. Remember these conditions up here. The sample is a random sample from the population, so it would have to say that it is a random sample of all U.S. teens. It doesn't say that, but it does say that it was a representative sample of the population. Based on a representative sample of 500 U.S. teenagers. So the first condition, we say that the sample was representative. Of the population of U.S. teens ages 12 to 17. Then the next thing that we have to check is whether or not our sample size is large enough. Can we get 10 successes? Can we get 10 failures? So we need to know P hat, and we need to know the sample size. The sample size was 511. So we check NP hat, right? Because we don't have P to check. So 511 times 0.64. That gives us 327. That is greater than or equal to 10. So that's the number of successes. Then 1 minus P hat. That'll be 511 times 0.036. And that is equal to 184, which is also greater than or equal to 10. So this, by checking that, it tells me that the sample size is large enough. So our conditions have been met so that we can use P hat in calculating our margin of error instead of P, which we don't know, right? So now we're going to compute that margin of error. The margin of error is going to be equal to 1.96 times 0.64 times 0.36 all over 511. We take the square root of that, multiply by 1.96, and we get 0.04, which is what they calculated up here. Okay, so now what we need to do is really the most important part. We can all punch numbers into a calculator and get a value. What we need to be able to do is interpret, what does it mean? Okay, so we need to very carefully and thoughtfully think about how to interpret this number, okay, of 0.04. So, and the knowing that our P hat was 0.64. So what we could say about this problem when we interpret it is that an estimate of the proportion of U.S. teens who favor keeping the legal drinking age at 21. Is 0.64 or 64% if you want to say that. You can say it is unlikely that this estimate differs from the actual population proportion by more than 0.04. So if we think about it, then if we added 0.04 to 0.64 and subtracted 0.04 from 0.64, we would have 0.6 to 0.68. And we would say that, it's likely, we're 95% confident that it's that actual proportion, the population proportion, is somewhere between 0.6 and 0.68, because it's not going to differ by more than 0.04. Okay, it's unlikely that.